Dear friends, welcome to another culture session with MSD Animal Health. Today, we have a veterinarian from Brazil, postdoctor at Saskatchewan University, with Dr. Matthios Costa, Jessica Barbosa. Welcome to join us, Jessica.
Thank you, Paulo. Thank you, everyone, for this invitation. I'm glad to be here to talk with you, to learn with you and talking about a very good topic that I like it, about intestinal health. So thank you for the invitation.
Oh, you are very welcome. Thanks for being here with us. We really appreciate Jessica. Jessica, you are from Minas Gerais, from Lavras. Please tell me your story, how you end up working with intestinal health in swine, and now you are going to Canada. Please share your story with us.
Yeah, I've never imagined before that I would be working with pigs, first of all, and after that I will be working with pigs in Canada. So when I started my undergrad in veterinary in Brazil, I started in Lavras in 2011. The second semester of my undergrad, I decided to do an internship with pigs. I've never imagined before how to work with pigs and everything. And since then, I fell in love with them, with the pigs, with the swine production world. And I started after, I joined in a research group that worked with intestinal health. And again, I fell in love with this intestinal health world. And, but when I started, I was working with animal nutrition. So nutrition strategies in controlling intestinal health. But I was always interested in how the enteric diseases are linked with intestinal health and how can we learn a little bit more with these and deal with enteric diseases. And some years ago, my professor, Vinícius Cantarelli, he made a partnership with Matthios Costa that lives in Canada and works at the University of Saskatchewan. And since then, I started working with Matthios Costa, especially focus on the host pathogen interactions, how we can learn a little bit more about pathophysiology and how the pathogens can interact with the complex intestinal health world structures and causing disease, and how can we make new strategies to overcome this challenge. So that's why I went to Canada, and I'm staying there, living this cold place.
No, that's an amazing story. And so you started this journey in 2011, and now you are going to Canada definitely.
I think so, yes. I will start in there with working a little bit more with research, and it's a good place to start, I think.
Congratulations for you. That's a great story. So Jessica, your expertise is research and in intestinal health and microbiome, is that correct?
Yes, I started with animal nutrition, but I was changed a little bit and I moved to work with enteric diseases, especially diseases that we don't have other approaches in controlling this disease, but we usually use antibiotics to treat the animals. For example, swine dysentery, and there we started to look at how the microbiota can impact the disease resilience or cause the disease in animals. So that's why I finished my PhD working with host microbiota pathogen interactions.
Oh, that's really good. Yeah, so we invite you here to help us to understand what is this field of research that is growing, and help us also to understand where this is going and what we can wait from this applied science in the near future. But if you can, you could help us understand a little bit more how microbiota is studied, how is the design of the studies, and what is a natural microbiota, and when you do a change, how is that process a little bit?
Okay, good question. And I always like to say that intestinal microbiota is a very complex word that we are starting to work. First of all, in human medicine, I think they are a little bit more advanced than us in swine industry. working with how the microbiota, the intestinal microbiota is linked to disease or health in humans. And we start to work with this in animal production because I think the intestinal microbiota is linked with a lot of body functions for us and for the animals. So we start to looking first before we have access to the sequencing approaches. In the beginning of like few decades ago, we start working with microbiome, looking who are there to try to understand which pathogens or which bacteria is there. But now we are looking for not just who are there, but what they are doing there. So I think now we are walking towards to understand what the environmental that is involved, and also the intestinal microbiota, what they are doing there to cause the disease or to make the animals be resilient against any pathogens. Working with microbiota or microbiome, we usually use these two words to say the same thing, but the meaning is different. The microbiota means that all the microorganism that is in a given place. So we use the biota is from a ecological study. That means any kind of organisms that is found in a given place, and micro is from microscopic, so microbiota is related to any kind of microorganisms that is present in a given place, in that case intestinal microbiota, the microorganisms that is present in the intestine. And it's bacteria, it's involved bacteria, virus, and fungi. And microbiome is the omic words, means the genome of a bacteria or other microorganism. And microbiome is the study of the collection of genes of each microorganism. In that case, in that case of microbiome, we are trying to understand, to identify, understand what they are doing by sequencing their genomes.
My question was, what would be the way you do this study? How you do is you look for the composition of different microorganisms inside the gut. And now you are saying that you are more looking for, not you are saying that, but the microbiome is the study of the genome, the genetics of the agents in there. And there is a transformation. In the beginning, people were looking for more, I would say the word demographic, the presence and the proportion of the agents in the guts, and try to define what is health or what is not. But nowadays it's more migrating towards to study what they are doing there, more than just the proportion of agents, what they are doing in the guts. Is that correct?
Yes.
Okay. So tell me, Jessica, what would be a big surprise for you from something that in the past you thought is this way, a paradigm shift in the last 2-3 years in the microbiome, something that caught your attention?
I think nowadays we still don't have a clear definition what is a health microbiota in pigs, in animals. We have this definition a little bit more clear for humans. I think in the next few years, when we start to understand a little bit better what they are doing there, we can maybe finally understand, okay, if we have some approaches to the piglets that we can make them develop this a better or a good microbiota, and the animals will be resilient to disease. I think that will be a very good surprise for us, because we understand better, okay, if we inoculate it, in my field, for example, in swine dysentery, when we inoculated the animals with Brachyspiral dysentery, we can see that there is some specific microbiome profile that can help the animals to develop the disease. But we are trying to looking for if we find some if we can design a microbiome profile that can help the animals be resilient, I think this will be a very good approach for us in the future.
They're very nice. And Jessica, when I think about swine, there is different phases of life of the animals. So you have the gilts that are under preparation to get in a sow farm. The sows have their reproduction cycling, and then they provide the piglets. The piglets has from birth to end of their life a range of is harvesting time from 20 weeks to 29 weeks, depends of the country, the region, or market. So when I think about microbiome today, where the science is looking more is the early stages of life of piglet, first 2-3 weeks, or is after weaning, or is more in the growing finish phase, or is it on the gilts or on the sows? Can you help me to understand where we are working today?
Yes, that's a very interesting question, and I think my answer for you, it depends, but we can see different research group focusing different stages of lives of the pigs. For example, we are looking, I started working especially with growing finished pigs, focusing swine dysentery and also salmonellosis, for example. And there's a lot of studies about Lawsonia intracellularis as well. But there's we are starting to pay attention a little bit more in how the transition from maternal, from sows to piglets, so in the early life of the piglets, how the composition of intestinal microbiome of the sows can influence the colonization by good microbes in the piglets. So I think that it's a very interesting topic for us to start to looking a little bit more in swine industry, because we can make strategies, novel approaches or strategies that we can apply in sows just to improve their health, intestinal health, and also it can be influences the intestinal health of the piglets and also the piglets' immune system and intestinal health development and also performance. I think that is a very interesting topic that the researchers are focused nowadays.
Very nice, Jessica. A curiosity. So when we are thinking about microbiome, we are studying what is in it, what they are doing, how things are going. And then there is the health. And there is then the other situation where we may change the gut with a Brachyspira or Salmonella, something in those lines. My question is, when we do these changes with the agent, the microbiota changes totally very quickly. And if it does, it's hard or easy to try to make this go back to manipulate the microbiota. Is something that reacts quickly or takes time? Is like weeks to get where we want, or is kind of an action that we can do in 1-2 days?
That is a very good question. In University of Saskatchewan, Professor Matthios Costa and Professor Joe Hardin, they have been working with challenge the animals with Brachyspira hydrantary or Brachyspira hampsoni to see what's happening in the microbiome, the profile before or after the animals develop the disease. And we can see that the animals, after they are inoculated, then the microbiome profile composition can change very quickly. And my research, for example, what we did was try to understand what happened 2 days or 1 day before the animals develop the mucohemorrhagic diarrhea, that is a classical sign of swine dysentery. So this was an interesting study because we did not inoculate the animals that I used for my study. So the animals, they were in contact with cedar pigs that were inoculated before. So we inoculated the cedar pigs, and after they start to have the sign of diarrhea, swine enteric diarrhea, we introduced them in a pen with animals that were not inoculated, the contact pigs. And when the contact pigs started to develop the diarrhea, the classic diarrhea of swine dysentery, we look at what's happened 2 days before they develop the swine dysentery clinical size. And it was interesting because we could find, like before the animals, already before they have the classical clinical signs of swine dysentery, that it's a blood diarrhea, they already start to have a shift on their microbiome composition. So it's not, I can say that it's a stable, okay, they will always have the change quickly. It will depend about the animal, how their own intestinal microbiota composition for each animal individual animals can also influence it, and we saw this in my study. It's a very complex word, but I can tell you that the microbiota composition can change. And if we find a microbiome composition profile that can be, the animals can avoid the animals developing disease, this will be interesting to try to manipulate the microbiome composition.
So the idea, if understood right, is you have a given microbiome, A, B, C, D, different ones, and do you do the challenge with a Brachyspira, let's say,
yes.
And then you study this microbiome really holds better, doesn't let the damage of the disease happen as dramatically as the other one. So you are trying to find something that is more resilient to the disease, is that correct?
That's correct.
So in the future we may then try to cultivate that kind of microbiome and give a system to make more pigs have that kind of a profile on their guts. Is that the direction?
That is the direction. I think it's a very good direction, especially because we are walking through to live without antibiotics or reduce the usage of antibiotics. So we need to look for novel approaches to make the animals be more resilient to the enteric pathogens or other pathogens as well.
Okay, and this management of this can be done by nutrition, different ingredients that you provide will favor more different kinds of profile of the gut, or is also inoculation? You provide some live microbials to the pigs. How more or less is the process? Is a combination of them, or there is something specifically you see for the future in this case, Jessica?
I think it can be a combination, because I think just one approach will not help us to solve all the problems, all the challenges we have. I think looking for a holistic approach, a combination of nutrition that we can manipulate the microbiota, for example, or other approach that we can try to manipulate it, and also other health approaches. I think it's a compilation of strategies that we can try to look a little bit more. We can try to understand better and apply to the swine industry. So I don't think it will be a good idea we focus only on one approach. I think it's the time for us to work with more than one strategies, for sure.
And Jessica, moving a little bit from microbiota, but stay on the conversation. You were talking about two different agents, Brachyspiras and the Salmonellas. But Brachyspira specifically, we know there are problems out there, but I don't know, I don't track too much the science today about prevalence of Brachyspira. What is your experience with Brachyspira prevalence?
I don't have a very good experience yet with Brachyspira prevalence, but I've been talking with other professionals. We have a high prevalence of Brachyspira swine dysentery in Brazil, for example, and in Canada also, that I've been there, we have a higher prevalence of Brachyspira hamsoni, and yeah, I think what I can say is that we have a high prevalence of Brachyspira in the system. It's in an endemic way, and that's why we need to. And Brachyspira, of course, can cause an economic impact to this swine industry. So that's why we are trying to understand how the host pathogen interactions, to see how can we control the swine dysentery in swine industry.
Dear Jessica, thank you very much for this great conversation. I really enjoyed to learn more about your field of study and what good answers and explanation you give to me. A lot of learning. Also, thank you for being here with us in Porto Vallarta for the high quality pork. Looking for the future of the industry and the challenges, and you're going to be here with us talk about the intestinal health, where we go to for the future. So we are really looking forward for your presentation. Thank you very much. And dear friends, this is one more coach session with the MSD Animal Health. Thank you very much for joining us, and goodbye.